In this video, we will see the loop optimization process. What is loop optimization means? We have to check whether the code inside the loop has effect or not. If it is not has effect means we have to move outside of that loop. That is called as loop optimization. Okay. So for that, we will see an example. Here totally we are having 5 blocks: block 1, block 2, block 3, block 4, block 5, and block 6. Okay, so here each and every block we have to check whether is there any loop is available or not. If it is available means we have to check how many times it will execute. Okay, then we have to check whether the code inside the loop has effect or not. If it has effect means no problem, otherwise we have to move out of that loop. Okay, that is loop optimization. So for that, first we will see the block 1. Okay, in block 1 we are having 4 line of codes. The first one, I equal to m minus 1, j equal to n, t1 equal to 4 into n, v equal to a of t1. Okay, here we are not having any loop. Okay, then we have to check is there any optimization process is possible or not. Okay, here I is evaluated only once, j is evaluated only once, t1 is evaluated only once, and we also evaluated only once. So the optimization is not needed. Okay, then come to the second block. In second block B2 we are having 4 line of code. Okay, here the first one, I equal to what? I plus 1. Second one, T2 equal to 4 into n. Then T3 equal to a of T2 if that T3 is less than V. Less than V means go to B2. Okay, B2 means again we have to execute the same block. Okay, go to B2, starting off B2. Okay, so here we are having looping process. So we have to check whether is all the line has effect or not in inside the loop. Okay, here what's the first statement? I equal to I plus 1. I equal to I plus 1. Initially we define I equal to what? M minus 1 in block 1. Here we are incrementing that I value by 1. So it has effect. The code has effect. Then come to the next line. T2 equal to what? 4 into n. Okay, here what is n value? What is n? 4 into n. What is n value? Is n value is incremented in anywhere inside? Inside B1 as plus B2? No. Here in B1, n value is used for evaluating T1. Okay, in B2 for evaluating T2 we used n. So here the n value is not incremented. N value is not incremented. So we have to check whether here the statement here the n value is not incremented means, okay, the T2 value is always remains same. Example, if you define n equal to 5. N equal to 5 means here what's the T2 value? 4 into 5 equal to 20. Okay, assume suppose the loop will execute 10 times means the 10 time the T2 value will remain same, that is a 20. So the code has no effect inside the loop. So we have to move that code outside of that loop. Okay, so where we have to move? So before that block 2 we have to move. So we just remove the code T2 from B2. Okay, and move outside of that loop. So automatically the T2 is removed. Okay, and where we have to add it means we have to add that into either block 1, otherwise we have to create a new block. Suppose in B1 we are having a loop means we have to create a new block, but here B1 we are not having any loop. Okay, so you just add that code to here, where we have to add here. Okay, before adding we have to check whether the same expression is already evaluated inside the block B1 or not. Yes, we already evaluated T2 equal to what? 4 into n. Okay, so the statement is not needed. The T2 equal to 4 into n is not needed for the block B1. Okay, so we just remove. First thing we have to check whether the code has effect inside the loop or not. If it has effect means no problem, otherwise we have to move outside of that loop. Okay, then we have to check whether the same code has already available in the previous block or not. If it is available means just remove that code from the entire process. Okay, so we remove. Then come to next one, T3 equal to A of T2. Here we remove the line T2. So we remove the temporary variable T2. So instead of T2, we have to use the variable name T1. Variable name T1, because T1 equal to what? 4 into n. So instead of T2, we have to use the variable T1. So you just remove T2, use the variable T1. Use the variable T1. So T3 equal to A of T1. A of T1. Okay. So here we have to use A of T1. A of T1. Okay. And next, if T3 less than V, T3 less than V, go to B2. Okay. The code has effect because we calculated T3 here. Okay. Then already we computed V in block 1. Then we have to compare the two variable. Then the condition satisfied means again we have to execute the same block. Okay. So the block has some meaning. Okay. Then come out of that block. Then come to the next one. The next one is what? Block 3. Here we are having 4 line of code. The first one, j equal to what? J minus 1. Okay. First we have to check whether the code has effect or not. Here we are decrementing j value by 1. Okay, where we define j? We define j at block 1, j value equal to what? N, and in this block we decrementing j value by minus 1. So the code has effect. The code has effect. Next one, T4 equal to 4 into j. Okay, here what's the 4 into j? Here j value is what? J minus 1. So the j minus 1 has effect. Also T4 also has effect. Okay, so just use that code. Next come to the next one, T5. T5 equal to what? A of T4. What is T4? T4 equal to 4 into j. It has effect. So just use that. Okay. Next come to next line. If T5. What's the T5? A of T4. A of T. What's the T4? 4 into j. What's the j value? J minus 1. So it also has effect. If T5 greater than V, go to again block 2. Okay, so in block 3 all the 4 line has effect. Okay, so just use that. We can't optimize anything here.